Hi, welcome back to Math's Playground. Today we'll be solving some AMC 8 and MISC problems. Okay, sort of forgot what MISC means, but that doesn't matter. Okay, so our first problem. A cricket randomly hops between four leaves. On each turn, hopping to one of the other three leaves with equal probability. After four hops, what is the probability that the cricket has returned to the leaf where it started? Okay, so let's draw this out because I don't know if it's possible without drawing it. So here's one leaf, here's two leaves, here's the third leaf, and the fourth leaf. So if we call this S, the starting leaf, and all three of these other O, so we're just going to list down some probabilities. So what's the probability that it will be at the starting leaf after zero hops? It's 1 because it hasn't started yet, which tells us that it's still at the starting leaf. So what's the probability that it's going to come back to the starting leaf in one hop? That would be 0 because in one hop it has to go to one of the O's. So now for probability that in two hops it's going to come back, we're going to draw some things out. So if it goes from S to O, the probability is 1 because it can't go from S to S because there's no other starting leaf. And then we want it to be back in two hops, right? So we're going to go from O to S. So say the cricket chooses this one. So the cricket chooses this random O, and then has to go back to S, and it can't go from the same O to the same O. Like it can't stay in one leaf in one hop because then it didn't go anywhere. So the S is one leaf out of the three leaves it can go to, and it says hopping to one of the other three leaves with equal probability, which means that going from O to S is 1 by 3. So we're going to multiply these because these are because these are like part of the same thing. So we get 1 by 3. And probability that it's going to be back in three hops, sorry. So we have S goes to O, which is 1. O from O goes to another O, which is 2 by 3 because at 1 O, let's call it this one. There's two leaves out of three leaves, which are called O from where the cricket can go to. So it's 2 by 3. And from O to S is 1 by 3. So it's 2 by 3 times 1 by 3, which is 2 by 9. A probability that it's going to be back in four hops, which is what we need. So here's our case 1 for this. Our case 1 for 3 hops. Now for 4 hops, another case 1 for 4 hops this time. From S to O, 1. O to O, 2 by 3. Then from O to O again is another 2 by 3. And then from O to S is 1 by 3. So we have 2 by 3 times 2 by 3 times 1 by 3. It looks like we can do a case 2 over here. From S to O, 1. Now if we go from O to S, that would be 1 by 3. From S to O, that is, from S to O, that's 1. And from O, so I'm gonna go this way because I see there isn't much space. So from O to S, we have 1 by 3. So we're gonna add 1 by 3 times 1 by 3, which is 1 by 9. So we're not gonna multiply these because this is, hold on, let me just move up here. This is what you call mutually mutually exclusive, and we call it mutually exclusive because they have an or relationship. It can't be it goes on case 1 and then it goes on case 2. It has to be either or. So there's an or relationship. So they're not exactly connected besides the or. I know I'm not making much sense right now. So when we add this, we can, I'm gonna go in the middle of these leaves now. There isn't much space. So let's multiply all 3 of these first. We get 4 by 27 plus 1 by 9, which is equal to 4 by 27 plus 3 by 27, which is equal to 7 by 27. And there's our answer. Okay, this took up a lot of space and I can't even read my work right now. Well, half of it. Some of it I can read, some of it no idea what I did. Alright, next problem. Right. If n is an even positive integer, the double factorial notation n double factorial, that's what I like to call it, represents the product of all the even integers from 2 to n. For example, 8 double factorial is equal to 2 times 4 times 6 times 8. So, what is the units digit of the following sum? 2 double factorial plus 4 double factorial all the way to 2022 double factorial. Alright, not to insult you or anything, but I know some of you are thinking, wow, this problem is so scary, I don't want to multiply all of this. Lucky for you, we don't have to. So we're just gonna go on, so we're just gonna find a pattern here. So 2 double factorial is equal to 2. 4 double factorial is equal to 2 times 4, which is 8. 6 double factorial is equal to 48. And then 8 double factorial is equal to 384. Yes, I did this. And then 10 double factorial, alright, would be 3840. Remember, the question only asks for the unit digit. 12 double factorial is equal to 46080. So notice how every double factorial, which is 10 and up, has to have a 0 as a unit digit because you're multiplying 10, because 10 is part of the double factorial. So we're going to, now it asks for the unit digit. So we're going to add all the unit digits of these 4 double factorials, because then everything's going to be 0, 0, 0, 0, 0, 0, 0. So we don't have to add all those zeros because we know it's going to be 0. And yeah, so 2 plus 8 plus 8 plus 4. So over here, the unit digit is 2. When we get to when we add these two, the unit digit becomes 0. Over here, the unit digit is 8. Then over here, the unit digit becomes 2. So our answer is 2. See, we don't have to multiply. Third question. Okay, our next question. Jamal has a drawer containing 6 green socks, 18 purple socks, and 12 orange socks. After adding more purple socks, Jamal noticed that there is now 60% chance that a sock randomly selected from the drawer is purple. How many purple socks did Jamal add? Okay. 6 green socks, 18 purple socks, 12 orange socks. So, sorry. Let's say he added S number of purple socks. So as you can see, this is obvious that this question is probability because there's 60% chance, special word in probability. So, yeah. So, 18 plus S out of, 6 plus 18 plus 12, which is 20, which is 36 plus S. So this is probability that he's gonna get a purple sock, which is equal to 60 by 100, right? And then, which is 6 by 10, which is 3 by 5. So now we can cross multiply. So we have 5 times 18, which is 19 plus 5s is equal to 108 plus 3s. So let's take the unknown value, which is s, to one side. So we get 2s is equal to 108 minus 19, which is 18. So s is equal to 9. Okay. So that's your answer. All right. The verification code for a website is a 4-digit number. Each digit can be anything from 1 to 9 inclusive, but the same digit cannot be used twice. Find the total number of possible codes. Ooh, I know we haven't done this in a long time, but this is a permutation problem. So, yeah, 1, 2, 3, 4 digits. So for the first digit, we have 9 options. For the second digit, we have 8 options because we cannot repeat a digit, times 7 options for the third digit, and 6 options for the fourth digit. So we have to multiply all of this. Try and multiply it mentally. If you can't do it, write it down. Okay, so 9 times 8. Alright, I've got it. The answer is 3024. You can even check it if you want. Alright, on to the last question. A restaurant offers a 10% discount to first-time customers. Ooh, lucky. If a first-time customer orders a meal regularly priced at $18 and pays a delivery fee equal to 15% of the discounted meal, how much does the customer pay for the meal, not including tax or tip? Alright, if this restaurant is real, I really want to go there. I'm starting to feel a bit hungry. Alright, so without discount, so if you like pay for it without discount, well, without discount it's $18. Now with um this with discount is 18 minus 1.8, which is equal to $16.2, which in money is $16.20. And now either you can, so now we have 2 ways to continue. Either you can find 15% of this and add it, or you can just multiply this by 1.15, which is 115%, and get the answer at once. So let's go with um multiplying it by 1.15. So 16.2 times 1.15 is 18.63. So which is $18.63. Wow, I can't believe you still have to pay more than the without discount. But yeah. See you next time.